All right, thanks for joining us. Chaos to clarity, and yeah, this is very chaotic here over the next couple of days. I don't remember a storm that's given me more trouble than this one. So let's get right to it. Let me sit up in my big boy chair. Let's talk about it. All right, first of all, the first ingredient that we've been talking about has always been the cold air injection, right? The injection's in. Let me show it to you. It's 7 o'clock. Let's do 1 o'clock Monday. A little farther south, but overall, I mean, nothing has really changed. Here's our area of high pressure this evening. Let me go to a 7 o'clock tonight. And, I mean, the cold air is right where I thought it would be, in here. Here's your area of high pressure. Here's your injection. Now, my thought was that's where the snow would end up being, but this area of the southern piece of energy has been a real bear trying to figure out where that's going to go. But the cold air is in. It's not super cold, but it's cold enough. All right, let me get to the 500 millibar here. I'm not going to be as long-winded as I've been in the past. I want to get you in so you can get an idea. All right, let me show you what's going on, and I'm doing something now. I'm doing something that I've never done before in my meteorological career, and we'll see if I get burned on it. I think the most accurate computer model we look at is the European. I do. It's right much more times than wrong, and I think it's better than the American models. However, I'm throwing it out. I'll show you why. Hopefully I do not live to regret that. Or hopefully, well, we'll see. Let me show you what's going on with this with that particular model here. Let me show you what's going on. So the contention the entire time is how does this southern piece of energy, and let me do some changes here really quick. Let's do that, and then I'll be able to compare them. So I want to show you this is the European model. All right, now watch what it does. Here's your southern piece of energy right in here. Here's your northern piece. Nothing here has changed. So this is out ahead of your northern piece. So this is going to be able to move to the northeast. No problems with that. Watch what happens as we go forward. It starts moving north. There it is. There's the European at 1 o'clock this morning. Then watch what happens. Here's the key move. When you look at this, you have the piece of energy back here. Here's your energy. I would just assume that this is going to continue to lift to the northeast. Now, here's the key. Why I care about that is because the way it moves, you generally get the heavy precipitation on the northern side of where you get this trough to go through. So I'm anticipating it moving to the northeast based on what I'm looking at right now. All right, watch what happens here as we go from 1 o'clock. And this is the key time frame. We've always talked about this. The key time frames from 1 o'clock to 7 o'clock. How does this energy move? Watch what it does. Boom. Doesn't move northeast. Moves due east. Almost due east. Why? Look at this little kink show up right in here, and we'll zoom in right here. Right here. See that? Little kink. So instead of it, and that is what pushes it and keeps it a lot farther to the south. Now, when I look at that, does that make sense? Where does that come from? Where does that little kink that you go from here, I don't see anything coming in the flow, how does that materialize? And when you look, it seems to come out of nowhere. You see that? Here's the GFS, which is the American model. So let me go back here. I got to get back. So here's the American model, same time frame. So there's the European, here's the GFS. Now, there's some difference in the modeling here. The GFS, there's the European, here's the GFS. You see, there's a lot more northern energy in here. See, a lot more energy in here, a lot more juice than the European. Watch, because there's the GFS. That's at 7 o'clock, 1 o'clock. Tuesday morning. There's the GFS. See the European? There's just much less energy. See? You notice that on the northern edge? And the other thing that you do not see with the GFS is that you don't see this kinking of the isobar coming east and pushing this eastward. In fact, the whole piece of energy, what does it do? It lifts to the northeast. Look at it. It lifts to the northeast. You can see it. Northeast, lifts to the northeast. So the 546 line goes from the upstate of, goes from Atlanta to almost near Raleigh. So it's lifting northeast. The European just pretty much goes due east with it. That makes a big difference. Let me zoom you in a little bit, a little closer, so you can get a little better sense of this. And I'm going to close the big ones, and we'll go to the small ones here. So here's the GFS. Look at that energy going northeast. You see that? And then here's the European, well to the south, right in here. And you'll also notice it just doesn't have a lot of energy. Look at 7 a.m. Tuesday on the GFS. Look at all this energy up in here, denoted by the yellow and red shading. You see that? Watch what the European does. Not there at all, because it brings this little kink in the right in here across the area. There's the European, GFS European, GFS European, GFS European, GFS European. You see that? So I'm going to throw it out. We'll see if that's right. But the other concern we have is with the precipitation. Let me show you this. As we go forward, here's the European. I believe this is the European. European GFS, 7 o'clock in the morning. Look at how far the precip is. Look how it's suppressed on the GFS, on the European. GFS European, GFS European, GFS European. Everything's suppressed. The concern we have is, listen, it's cold enough for snow in these areas in here. South of this area, it is very marginal about the snow. What I want to show you is the wet bulb temperature. This, what I'm showing you is the temperature that it's going to, the temperature that will, the air temperature that it will be cooled to once you start precipitating into the air mass. So this is what the temperature will be once you get precipitation. It's called the wet bulb temperature. This is 1 o'clock. This is 1 o'clock tomorrow morning. No, this is 1 o'clock tomorrow morning, 7 o'clock tomorrow morning. So look at around New York City, Philadelphia, where it's supposed to be thumping snow right at this time. Your wet bulb temperature is above 32 degrees. This whole area is above freezing. So that's the other part of the problem. That's part of the problem from New York City, all of Long Island, Philadelphia. Your wet bulb temperature is above freezing. So you're not getting down to freezing. You could be at 34 and 35. How are you going to accumulate in there? That's the real question. Now, the way in which this storm, assuming, and again, we're going to throw out the European, so we're going to show you the GFS. What we're looking at here is a storm that's going to be strengthening. 1 o'clock, there's 7 o'clock, and 1 p.m. Look at how it strengthens. So what happens is when you get a strengthening storm like that, on the northern edge of this storm, you get intense upward motion and intense precipitation. And with that, that's how New York City gets your snow. It is going to be raining most of tonight. Your time frame in this area, where wet bulb temperatures are above freezing. So this area in here, I'm going to go to 7 o'clock tomorrow morning. So in this zone in here, all of Long Island, even coastal parts of Connecticut, but this area in here, all in here, you're going to be snowing. You have a very brief window where you're going to be snowing and snowing hard. And in New York City and Long Island, that's going to be from 7 to noon. So you have 5 hours. You have 5 hours to get your accumulation. Let's call it 6. 7 a.m. Now, it may not even be at 7 o'clock. Maybe it's, say, 8 to 1. So you're still talking about 5 hours to get all of your precipitation. How much snow are you really going to get in that period? Now, with this storm strengthening, you're going to get some tremendous upward motion in here. I'm going to show this to you. Look, there you go. At 7 o'clock in the morning, you're at a 990 low. And then by the time you get to 1 o'clock, it's 983. So it's a strengthening storm. You're going to get intense upward motion. You see this little area in here. This is called cyclonic curvature. This should be snowing hard. But the question is can you really get in New York City? Are you going to be snowing so you've got 5 hours at most? How much snow can you accumulate in that 5 hours and accumulate on the ground? That's the real question. Let me show you our snow map, and then I'll get you out of here. So again, the worst of this storm is for New York City and Philadelphia is going to be 7 o'clock till about noon. It's going to rain before then. Now, you get north and west of there, assuming the storm comes up far enough north, and I think it is, let me show you the snow that you're going to get here. Let me show you our snowfall map. We have not made any significant changes. Listen, I know New York City is blocking Long Island. I'm going to show you a close-up here. So here's what we're thinking across most of the southern tier of Pennsylvania, northern suburbs of Philadelphia, toward the Harrisburg area, Lancaster, Hagerstown, in this area, central New Jersey, we're going 1 to 3 inches of snow. We have 1 to 3 inches of snow in the northwest suburbs. This 3 to 6 may come down into the far northwestern suburbs of Philadelphia. Philadelphia, like New York City, you have a brief window to get your snow. We have a coating to an inch of snow in Philadelphia, 1 to 3 inches in the immediate suburbs, 3 to 6 in the northwest suburbs. Allentown, Hazleton, State College, all in this area, you're around 3 to 6 inches of snow. You start picking up around Williamsport, Scranton, Wilkes-Barre, Scranton, the Hazleton area. I still like about 4 to 8 in Hazleton and around Scranton, but 4 to 8, 6 to 10, you're in that area, northeastern Pennsylvania, northwestern New Jersey in the 6 to 10, most of the southern New York area, and then in toward Boston, 6 to 10, Hartford 6 to 10. We're gonna put Providence in the 6 to 10 area right now as well. 3 to 6 coastal parts of Rhode Island. Let me show you the close-up map so everybody can see New York City. We have all of Long Island in the 1 to 3, although we do take that 3 to 6 just north of the city. Just north of the city, most of that's Westchester County, 3 to 6 inches, most of the coastal parts of Connecticut and Rhode Island. Once you get toward Danbury on north, that's where you're 6 plus. There's your 3 to 6 in Allentown. Coating the inch in Philadelphia, most of central New Jersey, 1 to 3. You start getting into the 3 to 6 area. Let's call it northern New Jersey, far northern New Jersey, 6 to 10. That's what we're going with for now. The move south on the European is concerning to me. Quite honestly, I've been on board with most of this snowfall map. I thought, for the most part, this snow would end up being a little farther north. I did not think we'd get this 6 to 10 this far south, or certainly the 1 to 3. Well, the 1 to 3 in New York City doesn't surprise me. So this has been a challenging forecast. The snow begins tonight, ends tomorrow. The end times will be by noon in central Pennsylvania, early afternoon, New York City, Philadelphia, late afternoon toward the Boston area. The question is do we get that little piece of energy coming around the northern edge like the European has and pulls this off to the south, and all of this is garbage and not many people get much snow at all. Why? Because then the snow becomes disconnected from where the storm becomes disconnected from the cold air. That's the real question. Right now, we're not going to go with that, only because everything else I see, all the American models, every American model is somewhere in this solution. The European models, including the UK Met European, are farther south. The Canadian has been farther south. So this is a big, big difference. But I don't want to change a snowfall map that we've had out for over 4 or 5 days on one model. And everything that I see right now, at least right now, this looks like a lot of energy that's coming up. There should be enough precipitation. Let's see if that's right. I hope that answers your questions. I'm going to leave this snow map up with you. Take a look at it. And then because of the concern around New York City, I'll leave this up as well so everybody can see it. I hope this answers your questions. Let's see how this works out. It's been a heck of a storm to try to forecast, I got to tell you that. And this has been one of the more challenging ones that I can remember in a long, long time. Yeah, I'll be glad when it's over. Thanks for following me. You can follow me on Twitter or X. I'm at AccuRayno.